Hello, welcome once again. Okay, so we are on section 5.3 and we will be doing that of 5.4 as well. I think these slides are very simple to go through. So we've talked about that of 5.1 and 5.2. The 5.1 actually got us into the probability distributions of our continuous random variable, and 5.2 we also did that of the standard normal random variable, and we got to know how to calculate probabilities from that. Okay, so for now, the idea we have now is to calculate the probability of a standard normal random variable. That is what? A z, whereby z picks a number in between what? Some bounds of -3, 3, -2, 2. Those were the things that we did in 5.1 and 5.2. But now we want to also calculate the probability given a general random variable, which is not what? A z. Know that the z has a mean of 0 and standard deviation of what? Of 1. So with this random variable, it doesn't have a mean of 0. It doesn't have standard deviation of what? 1. It's a general normal random variable. But the clue is that we can convert this general normal random variable to our z, and therefore use the idea that we use in 5.2 to also calculate what? These probabilities. So that is what you see here. Okay. So the way we're able to convert our s. So in case you have probability of s maybe less than some a, you want to convert this to what? Z. How do you do that? By formula, we know that z should be equal to what? S minus mu all over what? Sigma. So we have to use the same idea. This implies that if you have something like this, you have to write probability of what? Then you have to subtract the mean from our s and divide by s standard deviation. Then we do the same for a2, a minus what? The mean all over what? The standard deviation. Then this becomes some formula we know. And this is what the z formula. Okay. This is the z formula. So this becomes probability of what? Z less than our a minus what? Mu all over what? Sigma. Okay. So now we've converted this back to this, and we can apply the 5.2 how we do it. Okay. But with the use of our calculator, we can calculate straight away using our general normal random variable without converting it to z. But the challenge that might occur is that sometimes you don't know how high or how low you should go. Okay, since you are given probability that s is less than a, maybe a could be 100. Maybe a could be 100. Okay, so how low? So this would be your upper bound. But how low, or the negative infinity number for which you have to actually choose to get your accurate probabilities. That's why when you standardize it to get the z, you know that z will pick to -3 and 3. That should be the minimum and the maximum. So if you have any number, in case you want to find probability that z is less than a, then you can pick what? Now our a tends to some z star. Okay, so you can pick a number. When it is -3, you can pick like -100, -50. That is also minus infinity. Okay, but with s, sometimes it becomes very difficult to know how high or how low you should go. That's the only challenge. So let's get to it, because our calculator will help us get these answers. Okay. So we have some example here to get the probabilities. So we have a normal random variable s, which has a mean of what? 12.5 and sigma of what? 3.4. So we have to compute the following probabilities. So we want to find the probability that s is less than what? 13. So since this is a normal random variable, it has that bell curve, and you can locate the mean here. Okay, you can locate the mean, and you want to find the probability that s is less than 13. So this is the mean, so 13 will be here. So you want to find this probability, the area, the region here. You want to find what? this region. Okay, in case you don't want to use the S, then you can convert it to also what Z. Then you're going to get the same answer. So with respect to this, now we always use the mean of what 0 and standard deviation of 1. But now we're going to use the mean of what the mean given by our random variable, which is what 12.5. And we are going to use the standard deviation of what 3.4. Note, when the variance is given, note that you convert it to what the standard deviation before you use it. You don't use the variance. So take the square root of the variance, you get a standard deviation. It's really, really important. Now our upper bound is 13. Okay, so you can choose a lower bound. So we are going to the negative infinities. Okay, so you can choose a negative infinity number. So it could be minus 1,000, minus 500, minus 10,000, minus 99999. Okay, you can choose that as what as a lower bound. So the lower bound here is not unique. Okay, because it has no bound. S goes to infinity. So here we choose what minus 100. So input these numbers in your calculator and you're going to get the respective probability. You're going to get the respective probability. So that's what we did. Okay, so use the same idea that I actually did in that of 5.2 and use how I calculated there. So now let me do one example here so that you get what I'm trying to say. Okay, so you press your second, you press the verse, you choose the second, that's the normal CGF, you press your enter. Now, what is your lower? Your lower is minus something, so minus 1000. Okay, then your upper will be that of what is the upper? The upper is 13. Okay, so the upper is 13. That is very. And now the mean changes to, we have the mean to be 12.5. And the sigma is 3.4. Then you paste this, then that's what's gonna give you your probabilities. So the probability is 0.5584. Okay, so that is the probability. But in case you don't want to use the mean of what is given, then you change it to Z. So Z will have a mean of 0 and a standard deviation of what 1. Then you calculate your Z value. So this will be your Z value, and that is going to also give you the same answer that we had here. Okay, so now you wouldn't use 13 as for the upper bound. You use the Z value that you get from calculating this as your upper bound. Then you can choose an infinity number that you want. Okay. So that is the main idea of that. So here we also have what the lower bound to be 8. So I think it is going to use the same mean. The mean is 12. The mean is 12.5 and the standard deviation is 3.4. Okay, so we have the lower bound and we have the upper bound and we get 0.4656. Okay, you can also change this. So with respect to this, in case you want to convert it to Z, then what you do is that then the probability of 8 less than S less than 13. In case you want to convert it to Z, then it implies that it's the probability that you pick 8 and subtract the mean from it, that is 12.5, and divide by the standard deviation of 3.4 is less than S minus what? 12.5 all over the standard deviation, which is 3.4. Then this is less than what? So the upper bound is 13 minus 12.5 all over 3.4. So this tends to, so it's going to be probability of a value here. You're going to get a value here. It's less than, so this is our Z. So this is the Z formula. So we bring Z and we're going to get another value here. Okay, so you've converted everything to Z. So this should be your lower bound and this should be your upper bound. But note that now Z has a mean of what? 0. That's mean will be 0 and sigma will be 1. Okay, you're going to get the same answer as you get here. But in case you don't want to convert it to Z, then you can use this value here and maintain the mean and the standard deviation for our S. Okay, using the calculator. All right, so let's check. So we have the length of gestation for swine is normally distributed between 114 So we have the mean to 114 days and standard deviation to be 0.75 days. So we want to find the probability that the litter will be born within 1 day of the mean. So we have the mean, so within 1 day, so we want to create some bound. Okay, so we add 1 to the mean and subtract 1 from the mean. Okay, so that is from 1 day earlier to 1 day later from the mean. Okay, so we subtract that and we have the bounds to be what? 113. So the lower bound is 113, the upper bound is 115, and this is the mean. Okay, so in case you want to find the probability that S lies within this. So I want to find the probability that 113 is less than S is less than what? 114. Okay, so this is the probability that you are finding, and this will be my lower bound, this will be my upper bound. Then I put in the mean and the standard deviation for S. Then I'm good to get a probability using the calculator. Okay, I've shown you how to use the calculator. Okay, so the same approach applies here. I want to find the probability that S is less than 14. So we have the mean, we have the sigma. Okay, so S is less than 14. You can pick a lower bound. So in case you don't know how to pick this, so you're going to the negative infinities. Okay, S is less than 14. So you're going to then you can pick a negative number. You're going to the negatives. Pick from 14 to the negative. So you can choose negative 1,000, negative 100. It's not unique. Okay. Then you choose your upper bound. Your upper bound should be unique. That is 14. And the mean is what? 10. We have it here. The standard deviation is this. Note, I repeat, if you are giving the variance, note that you convert it to standard deviation before you use it. So let S be a normal random variable with mean. 12 and standard deviation. All right, so the same thing. So now we've changed our mean, we've changed our standard deviation. We apply. So I want to get the area to the left. Okay, so this is the area we want. Using the calculator, you'll be able to get this area. Okay, so now we want to find. So now we've given another mean for our S normal random variable and the standard deviation. So now we want to find probably that S is greater than 13. So either you convert this to Z and use the mean for Z to be 0 and standard deviation of mean of Z to be 1, then you can do it. Or the calculator, then you have to use the upper bound. So we pick 13 from 13 to infinity. Okay, so the least, so the lower value here will be 13 and the upper value will be something positive. Some positive what? Infinity number, right? So the lower bound is 13, the upper bound is, we chose 100. You can choose 1,000, it's not unique. And the mean and the standard bets, if you are to convert this S to Z, then you're going to get different values for this. Okay, and the mean here will be 0. The mean here will be 0 and the standard deviation here will be 1. Okay, and we're going to change this to Z. So it's going to be 13 minus what? Minus the mean, that is what? 20, all over the standard deviation, which is what? 3. So you solve this, you're going to get a Z value. So use this Z value. Know that the mean is what? You're going to get the same value. You can try. It. Okay. Get the same probabilities. But in case you wouldn't be able to calculate this, then you can use the mean for S and the standard deviation for it. So you apply the same idea here, the lower bound. So you have the lower bound, you have the upper bound, and you have the mean of it. You have the standard deviation. Then you put this in our calculator, we get the answer. The same thing applies here. We are good to go. All right. So note that you learned that of 5.2 very well. That will help you understand what I'm doing. Very simple. So here we have two machines and it's available for cutting cork intended for use in wine bottles. The first produces corks with diameters that are normally distributed with mean 3 cm and standard deviation. So there's the first machine. Okay. And the second machine produces cork with diameters that have a normal distribution with mean 3 point and standard deviation. So acceptable corks have diameters between 2.9 cm and 3.1 cm. Which machine is more likely to produce an acceptable what? Cork. Okay. So now we want to find a probability that a machine can produce an acceptable cork within this what centimeter. So we are going to have our upper bound here. We're going to have our lower bound for one of the machines here and the upper bound here. Then we use its respective standard deviation and its mean to calculate the probability. Then we choose the same lower bound and upper bound what for the second machine. Then we are going to use its mean and its standard deviation to also calculate the probabilities. Afterwards, we check the one with the highest what probability, and we will choose that. Okay, indeed. So we have the lower bound. So one of the first machine. So this is the first machine. It has mean of this and standard deviation of that. And the second machine also has mean of this and standard deviation of that. Using the same lower and upper bound to calculate their probabilities. So the first machine gave us this probability and the second machine also gave this probability. So this implies that using the second machine, we are more likely to produce an acceptable cork within this interval. So the second machine works. So the second machine will be more useful. Okay. Now we are given a data S, we standardize it too. So what we've been doing is that we are given a data, then we can also standardize it to a Z and then calculate probability of the region. Okay, that's the area under the bell curve using this formula. So we give our data, then we calculate probabilities. But what we're going to do at 5.4 is that here we'll be given the probability and we'll be asked to find our S back or our Z back. So we are using the inverse. So always what you know is that we've been doing probability of maybe S is greater than 2.5, then you get the probability to be 0.93. Okay, so now we erase this part. We don't know it, but we know this part. So we are going to have probability that S is greater than maybe S star. Okay, which gives us 0.93. So we've been given this, then we are told to find that. So that is what we are going to do. This implies that our S here should be what? Our S here should be 2.5. Are you okay? So this is what we are going to do for 5.4. We know how to do this. Without knowing this, we can calculate this and find this. And now we know this and we want to find what this is. Okay. So that is the idea for 5.4. Okay. See you there soon.